Cosmologists have been fascinated by a red, incredibly huge star in the star cluster Orion for a very long time, but it is far bigger and more massive than our Sun. Betelgeuse has been acting especially in the following years. It has significantly decreased and has even begun to vibrate violently. This has led to speculation that this once brilliant star is about to explode in a big way. But consider the likelihood that Betelgeuse will collapse on itself rather than explode. Consider the potential that we are actually witnessing the beginning of a more deceitful and unsettling event. Come along as we examine the most recent findings regarding Betelgeuse and its possible effects on the environment. We hope to learn more about the potentially significant impact Betelgeuse's collapse could have on the cosmos' future via this inquiry. One of the biggest stars in the cosmos, Betelgeuse, often referred to as Scarab Jew, is a huge star that is many times bigger than our Sun. But being so big has a price. Stars like this don't live very long, and Betelgeuse is no exception. The precise moment of the device's detonation is still unknown, but it's a ticking time bomb. As one of our nearest stars, Betelgeuse, which is located about 650 light-years away, has captivated astronomers. As we attempt to discover the mysteries buried inside its flaming depths, we are astounded by its brilliance. But we can only see 13.3% of its bright energy. It would perform better in the night sky than even Sirius if we could see it in all its splendor. Imagine a massive star that stretches past the asteroid belt and nearly reaches Jupiter, with a range several times greater than that of our Sun. Earth, Mars, Mercury, and Venus would be submerged under Betelgeuse's immense gravitational pull within this enormous region. But the surprises don't stop there. Every few hundred years, Betelgeuse pushes off its outer layers in a stunning display of immense magnificence, shedding a solar mass. Betelgeuse is shrouded in a veil that catches our attention, encircled by a cloud several times bigger than the star itself. This cloud, stretching out over 30 light-years, entices us to explore its mysteries and join it in a magnificent cosmic dance. We should explore the core of Betelgeuse's genesis in more detail, which is the massive explosion that results from the atomic fusion of hydrogen to helium. As the star's hydrogen fuel runs out, helium combines with carbon to create light that travels the cosmos, causing a celestial transformation. But even this exquisite union has its limits. A startling transformation happens when neon solidifies with iron. Weakened by its energy loss, the star's gravity brings about an imminent collapse that sends Betelgeuse hurtling toward a fate that is both breathtaking and catastrophic: a cosmic explosion. Betelgeuse's destiny is a captivating metamorphosis from the vivid blues of childhood to the fiery reds of adulthood. Chinese astronomers observed an unusual occurrence in the 2nd century BC. Betelgeuse was distinguished from the sky by its unique yellow hue. As the ages went by, Greek and Roman astronomers like Ptolemy in the 2nd century AD inherited the rod of observation. He described Betelgeuse's appearance, which continues to captivate us, as being orangish or tanned in his meticulous notebooks. The mystery surrounding Betelgeuse is increased by this enduring tone, which has been noticed by observers from many cultures, including the Middle Ages. As we learn more about Betelgeuse's erratic behavior, the tale takes a new turn. Analysts were taken aback in 2019 when the star abruptly darkened. At first, scientists thought that our vision had been blocked by a tremendous dust storm that had been blown out of the star's surface, but they are still unsure of the cloud's source. Some scientists hypothesize that the star may have been eaten by or disturbed from its surface by a huge object, such as a planet. Betelgeuse's brightness has increased recently, nearly tripling from its typical level. This is unexpected because stars usually become dimmer with age. Although the reason for this abrupt spike in brightness is unknown, scientists are aware that a variety of reasons can cause celestial iridescence to change. Certain stars, for example, alternate between bright and faint phases. Because Betelgeuse constantly expands and contracts, varying its brightness and hence varying the amount of light it produces, it is categorized as a variable star. Many stars, like Aldebaran and perhaps 30 other stars that are visible in the night sky without a telescope, frequently exhibit this phenomenon. And tremendous dust fog is being created by the ejection of flaming material into space, causing a seismic change inside Betelgeuse's core. A large percentage of Betelgeuse's dazzling light was obscured by this dust cover, turning it from a magnificent guide to a faint glow in the night sky. Betelgeuse's brightness plummeted to previously unthinkable levels. Formerly ranked among the top 10 brightest stars, it is now less brilliant than the 20th brightest. Astronomers have been astonished by Betelgeuse's recent activity, which defies accepted notions of stellar behavior. There are a lot of theories out there that try to explain Betelgeuse's unexpected actions. Its sharp variations are thought to be caused by large sunspots or dust mists, although some people also look for potential repeating patterns. The disturbing theory that Betelgeuse's cosmic explosion might have already occurred has been revealed by their investigation. You did really hear correctly. Its cosmic explosion event was previously estimated to be millennia away, but new data now points to a different conclusion. The Kepler supernova, the last significant cosmic explosion in our galaxy, was visible hundreds of years ago. According to a model put up by researchers, Betelgeuse may be close to exploding significantly since it is already burning carbon. This puts it in a prime position to be the next big cosmic explosion in our Milky Way, akin to the concerto grosso of a celestial symphony. One of the leading candidates for the upcoming stellar cosmic explosion in our beloved Milky Way galaxy is still Betelgeuse. But researching Betelgeuse is like trying to piece together a puzzle with contradicting evidence. On a smaller scale than our Sun, there are indications of material discharges and subsequent recovery that point to a mass release event. The matter is complicated by observational challenges and appearance of cosmic explosions. The problem is that it's currently impossible to monitor Betelgeuse accurately. After years of research, scientists have discovered that Betelgeuse's brightness has changed. This implies that the star is getting older and may shortly go supernova, albeit there isn't enough data to pinpoint the exact time of this event. When a star dies, an extraordinarily bright event known as a cosmic explosion takes place. It is safe to witness with the unaided eye from Earth and poses no threat to life as we know it. A key player in the stellar life cycle in our galaxy is Betelgeuse, a red supergiant in the constellation of Orion. Its evolution provides important insights into the latter phases of stellar life and the effects of supernovae on the cosmic climate, as well as a glimpse into the future of other big stars. We must go more into Betelgeuse's star structure, life cycle, and wider ramifications of its possible explosion in order to fully comprehend its significance. Classified as a red supergiant, Betelgeuse is the product of later stellar evolution. Massive stars like Betelgeuse use up their nuclear fuel more quickly than smaller stars, which burn through their hydrogen fuel more slowly and go through a red giant phase. The star's outer layers expand as a result of this fast consumption, giving rise to a supergiant. Helium and heavier elements like carbon and oxygen make up the majority of Betelgeuse's fundamental composition. The star expands as a result of fusion events that start to take place in the outer layers after the hydrogen in the center is exhausted. This process, which ultimately leads to the star reaching its supergiant stage, is controlled by the intricate interaction of radiation pressure and gravitational forces. Betelgeuse's basic fusion mechanism is still what gives it its size and brightness. In the beginning, helium and hydrogen combine through a sequence of processes that produce a tremendous amount of energy. The core shrinks under gravity as hydrogen is used up, raising the temperature and pressure. Helium can now fuse into heavier elements like carbon and oxygen as a result. During this phase, the star's outer layers drastically expand, giving it its huge size and distinctive red color. Because of the high mass of supergiants like Betelgeuse, this procedure is more intricate. Several fusion processes occur in the core, resulting in a sequence of concentric shells where various components are fused. Every step of fusion modifies the energy production and composition of the core, which affects the star's dynamic behavior and possible instability. Betelgeuse won't have enough energy to counteract the gravitational pull of its own mass once its nuclear fuel runs out. This causes the core to abruptly collapse, which sets off a cosmic explosion. A swift succession of events comprise the supernova mechanism. First, the core collapses due to insufficient pressure from fusion reactions, allowing the core to collapse under the force of its own gravity. The core is compressed into a neutron star or black hole, depending on its mass, by this incredible rate of collapse. Second, A tremendous shock wave is created by the collapse and travels outward into the star's outer layers. This is known as shock wave formation. The material around gets heated by this shock wave and explodes in a dazzling display of light and energy. Ultimately, the star's outer layers are blasted into space, adding heavy components to the intergalactic medium around it. By helping to create new stars and planetary systems, these expelled materials contribute to the ongoing process of cosmic evolution. The surrounding landscape is significantly impacted by Betelgeuse's explosion. A supernova's ejected components can have an impact on how new stars and planetary systems originate. New stars can be created when the explosion's shock waves cause neighboring molecular clouds to collapse. Furthermore, the hefty components created in Betelgeuse's center and released during the explosion add to the universe's chemical enrichment. These components are necessary for the emergence of life and the construction of planets. As a result, the life cycle of Betelgeuse is essential in determining the chemical makeup and structure of our galaxy. Betelgeuse has been a recurring phenomenon in the night sky since ancient times, affecting many cultures and astronomical research. The peculiar color and brightness of Betelgeuse were among the celestial bodies that early civilizations frequently saw and documented. Throughout medieval Europe, there were a number of folktales and heavenly beliefs connected to Betelgeuse. It was a notable landmark in the night sky because of its reddish color and prominence within the constellation. In many cultures, its visibility and fluctuating brightness were taken to be omens or signs. Because of its strange behavior and the possibility of a cosmic explosion event, Betelgeuse has drawn the attention of astronomers in the field of modern space science. Thanks to developments in observational technology, such as space-based telescopes and high-resolution imaging methods, scientists have been able to examine Betelgeuse in extraordinary detail. Researchers track Betelgeuse's behavior using a variety of techniques, such as spectroscopy to examine the star's makeup and photometry to gauge brightness variations. Scientists can forecast the star's future evolution and grasp its current status thanks to these observations. Accurately estimating a supernova's exact timing is a difficult and demanding process. Based on a star's age and history, scientists can predict the chance of a supernova, but accurate predictions are challenging because of the numerous variables. The mass, makeup, and general surroundings of the star, among other things, might affect the explosion's timing and type. Supernova mechanics and stellar evolution models available now offer important new perspectives, but there is still much to learn about the precise circumstances leading up to a supernova. To improve these models and deepen our comprehension of these amazing cosmic occurrences, more observations of Betelgeuse and other large stars are essential. Studying Betelgeuse offers important new information on star evolution. Through an analysis of the star's behavior and features, scientists can learn more about the mechanisms that lead to supernovae and the life cycles of other big stars. The peculiarities of Betelgeuse, like its size, brightness, and unpredictable behavior, provide important insights for creating and evaluating theoretical models of star evolution. Furthermore, astronomers can better comprehend the larger picture of star creation and cosmic evolution by examining Betelgeuse's activities. New stars and planetary systems will form as a result of the star's interactions with its surroundings and eventual supernova, which will contribute to the ongoing cycles of cosmic development. Because of Betelgeuse's spectacular conduct, astronomy has become more popular and has captivated the public's attention. Popular science articles and educational outreach programs frequently use Betelgeuse as an illustration of the dynamic and intriguing processes taking place in the cosmos. Participation in public discourse on these subjects promotes scientific curiosity and a deeper comprehension of cosmic occurrences. Future studies of Betelgeuse will offer even more in-depth understandings of its behavior and evolution as technology develops. Scientists will be able to track the star's activity more precisely thanks to new telescopes and observational methods, which will also reveal more hints about the star's imminent supernova. To gain a deeper understanding of the processes taking place inside Betelgeuse and other large stars, researchers are now investigating the use of computational models and simulations. These models aid in forecasting the star's future behavior and advance our knowledge of the processes that propel supernovae. A fascinating glimpse into the life cycle of huge stars and their effects on the galaxy can be obtained from the study of Betelgeuse. cosmologists continue to be fascinated with Betelgeuse because of its enormous size, intricate fusion processes, and its role as a supernova candidate. Learn a great deal about the dynamic processes sculpting the cosmos as we investigate and study this amazing star more. When it finally explodes, it will not only be a remarkable cosmic event, but also add to our galaxy's continuing pattern of star formation and chemical enrichment.